Hello everyone, welcome back to my YouTube channel Summarized AI. In today's video, we are going to break down LangGraph and all the key graph components. This will really help you build strong fundamentals and give you a solid head start in understanding knowledge graphs also. Let me be very clear here. LangGraph often uses knowledge graphs as a structured knowledge source, but LangGraph itself is a workflow and reasoning framework, not a knowledge graph. Keeping this in mind, let's start our discussion with LangGraph and think of it as a smart flowchart for AI conversations. Imagine you are teaching a very smart assistant on how to do a job. A simple assistant works like you ask a question, it answers, conversation ends. This is simple. But a real world assistant works very differently. Before answering, it will think, decide what to do next, use tools, check results, fix mistakes, repeat steps. Stops only when the task is truly complete. This is exactly the problem LangGraph is designed to solve. And this is a simple example of LangGraph having all nodes representing start, thinking, tools, decisioning, and end. LangGraph lets you design AI behavior like a map with connected steps known as nodes. Each node can make a decision to call a tool or move to another step based on the result. Just like Google Maps chooses different routes depending on traffic. Before we go into details, let's first try to understand the graph and all of its components in general. There are some of the important components in graph like vertices, edges, path, connected components, cycle, and weight. Now, let's have a detailed discussion on all of these graph components one by one. I have converted our earlier LangGraph into a general graph. Let's start with vertex, also called as node, which is the fundamental unit of graph. It represents an entity or a point in the graph. More than one node gets called as vertices. Here, from node 1 to node 6, including the start and end node, are all vertices. Any single node here, even it is not connected to any other node, is still called as vertex. Now, let's try to understand the edges. Connection between vertices, either it is directed as arrows or undirected, known as edges. An undirected edge is a connection between two vertices without any direction, which means the relationship goes both ways. For example, the edge between node 1 and node 6 vertices colored in purple, which is this one. And a directed edge has a specific direction from one vertex to another, which means the relationship goes only one way. The edge or arrow in between start to node 1 or node 1 to node 4 colored in black are examples of directed edge. So whatever arrow you are seeing here, all are representing the directed edge. Let's talk about path. A path in a graph is a sequence of vertices where each consecutive pair of vertices is connected by an edge. Path can exist in both directed and undirected graphs. Edges highlighted in red from start node to end node having node 1, node 4 and node 5 in between collectively called as path. Point to be noted, paths can exist for both directed and undirected path. So here this path is starting from start, node 1, node 4, node 5 and end. So this is a complete path which is a sequence of vertices. Now let's talk about different types of paths we have in graph with the help of four nodes, node 1, node 2, node 3 and node 4. First one is simple path in which no vertex is repeated except possibly the first and last if it forms a cycle. Now this is cyclic path. So path where start and vertices are same and forming a loop called as cycle or closed path. So you see here it is starting from node 1 going to node 2 and node 3 and then node 4, and again it going back to the node 1, and again it is starting the cycle. So this is nothing but cycle or closed path here. Now the path that contains only a single vertex and no edges called as trivial path. In a directed graph, the edges always must follow the direction. Now, the last we have path, and it represents the total number of edges in the path. Here we have three edges in total, so the path length is 3. So one is this one, second, and then third. Now, if we have only three node 1, node 2, and node 3, then the path will be 2 because we have two edges. Now here we have two edges in total. So the path length is 2. Let's talk about connected components where every vertex is reachable from every other vertex in that subgraph. And there are no connections to vertices outside of this subgraph. Let's try to understand this with example. Here we have three different connected components. In component 1, every vertex is reachable from every other vertex like node 1, node 2, and node 3 in this subgraph. And there are no connections to vertices outside this subgraph if you see component 2 and component 3. So in component 2 also we have node 7 and node 8 connected in this subgraph. Similarly, we have node 4, node 5, and node 6 for component 3. Let's discuss cycle in graph, which is a path in a graph where the start and end vertices are the same and all other vertices in the path are distinct. That is, no vertex repeats except the first and last. This is also called as simple cycle with no vertex repeated. This is also called as directed graph as all the edges are following direction. On the other hand, this is an example of undirected graph here. The path loops back to the start and ignoring direction. Now, let's talk about weighing graph. Edges can have ways representing cost, distance, or strength of connection. Ways can be applied to both directed or undirected edges. In this weighted graph, each number of an edge is its weight, representing the cost, distance, or strength to move from one vertex to another. For example, an edge with weight 5 means moving between those two nodes. For example, node 5 to node 3 cost 5 units, while an edge with weight 2 from node 1 to node 5 is cheaper and closer. This way, we can choose most efficient or optimal route between vertices. Let's try to understand the differences in between LangGraph and LangChain. LangChain is a framework for building LLM-powered applications with the help of predefined workflows. In LangChain, you defined a fixed sequence of steps which executes flow from top to bottom. For example, provide a prompt to LLM and it will refer to tools. Tools are nothing but Python functions before providing an output. It is easy to build and pretty straightforward. LangChain is best for defining simple workflows, to work with RAG pipelines, develop quick prototypes, and write linear logic. On the other hand, LangGraph is built on top of LangChain, and it is designed to develop stateful graph-based workflows. It is basically a graph of nodes, not a straight line. And how things works in LangGraph. You define nodes like boxes here which represent actions such as LLM calls, tools, which is nothing but Python functions This is what we discussed, and conditional or decision logic. And also the edges as arrows represent how execution actually flows. LangGraph is best if you're working with complex agents that need to think in multiple steps, reason through problems, and retry or reflect on their answer. Since LangGraph maintains state throughout the workflows, it's ideal for stateful applications and production grade agents that require reliability, control, and scalability. And this is all I had on LangGraph and graph in general for today. In the next video, we will explore knowledge graphs and why they play a crucial role in developing AI/ML search and recommendation based applications. Thanks for watching this video. Please don't forget to like and hit the subscribe button. Thank you.